Hello. A small disclaimer, at the end of this presentation I will share the link with the slides just in case if you want to find some mentioned plugins or web links. Also feel free to use this presentation as instruction. It's intended to be this way. So let me introduce myself. My name is Sergei. I work at Mira. I arrived there from Amsterdam. And I'm a platform engineer responsible for Mira builds of monolith application and microservices as well. Today we will talk about building huge Maven applications, possible bottlenecks, finding them, addressing them. Also, we'll discuss several practical advices how to address issues with the performance of your build and look into details how the Maven itself works under the hood to understand why there are those problems. At the end, we will also compare the two build tools, Maven and Gradle. So, for me, the story started about 4 years ago when I joined Mira as an engineer, and I realized that there are a lot of issues with existing Maven application. It was building pretty slow. I was complaining, other people were complaining, and obviously the problem were only growing because more and more people were joining the company. Project was growing pretty rapidly, and we needed to address those problems. So I started discovering actually how things are working and how we can manage this. And today I would like to share some insights because one of the possible ways for sure was considered is to migrate from Maven to Gradle. At this point I was very impressed by their promo materials, promising like huge boost in numbers, like 50, I don't know, 100 times faster, but the reality is quite different. We'll talk about this as well. Maven is a very popular build tool. Who of you is using Maven in your projects? Nice. This is very popular for existing projects. This is very popular for new projects, despite of all advantages of Gradle. And one more thing, even if eventually, for some reason, you will make a conclusion to migrate from Maven to Gradle, don't worry. Advices from this presentation will give you valuable insights, and your codebase will be more healthy in any case. So let's start with something pretty trivial. I hope engineers of your organization have fancy MacBook laptops of Apple with Apple Silicon, or maybe Windows laptops based on ARM. We need just to ensure which JDK we're using, if it's built for ARM architecture or it's emulating x64, while Rosetta emulation, which is technically called translation, if I'm not mistaken, is a pretty convenient option. It has a significant performance overhead, at least 40% and maybe even more. We can easily find out which JDK version is used with Maven-V and pay attention to this parameter. But also, once you can find this on your local machine, you need to ensure in the future, if your engineers of your organization use proper JDK or not, you can implement your own validation like this via plugin or extension. It can be even a shell script, or use existing one that has like a very simple configuration. It will either print the warning or just fail the build. The next interesting factor, which is not obvious, is that each new JDK release has not only new language features and other cool things, but surprisingly, each new major JDK release has a better performant Java-C compiler. So this is one more reason to keep it up to date. Also, the vendor of the JDK can make much sense. Surprisingly, for example, Oracle is not the best here, but your results may vary. I recommend you to try different versions, and you can be surprised how different they are. Another factor, it's Java projects are not only pure Java, but it can be Kotlin, pure Kotlin, or mixing Java and Kotlin on the same code base. In this case, I strongly recommend you to upgrade the Kotlin version to the second generation, because JetBrains made a just excellent work rewriting the compiler almost from scratch. Don't be confused. The runtime compatibility is kept in a very good way. And when we're talking about Kotlin 2.0, it's not about breaking compatibility, but the new Kotlin compiler and tooling. So if your project is relatively small, it's okay to do it like in one go. But if you have a huge code base, I recommend you to do it in 3 steps. So first upgrade to latest 1.9, then to upgrade to 2.0 with the 1.9 compiler mode. So JetBrains made very smooth migration, so they saved the original compiler in the second version just for compatibility. So you can do it in a multi-step, and then finally switch to K2. You will notice significant boost in the performance of your builds, even if you're mixing Java and Kotlin in the same code base. Now let's talk about more complicated thing. Historically, Maven never had built-in cache solution, but nowadays, Apache suggests so-called build cache extension. So what is build cache? It's a pretty simple thing. Instead of executing heavy and expensive operations that require CPU and memory, like compiling, running tests, and code generation, if the inputs are the same and we consider the behavior of the compilation as deterministic, it means that it will always produce the same output. Instead of executing those tasks again and again, the result can be obtained from cache. So there are 2 types of caches. It can be local or remote. So local caches are saved in the local file system. Remote caches are usually used in CI/CD via like HTTP remote services. So option that you should be aware is mentioned Apache build cache extension, which can be added by the MVN extensions, and it has few advantages. For sure, it's free and open source, supports local and remote caches, but also it has few disadvantages. It's pretty slowly evolving. Last major release was more than a year ago. It needs detailed configuration, and I would call it like fragile. It's easy to make a mistake here. And for example, for Mira, it just doesn't work because it does not support test distribution, test selection, etc. And the last thing, it doesn't have so-called, there's a typo, no build scans. What is build scan? We will talk about this now. Another solution is Develocity, which you may know as Gradle Enterprise in the past. Extension, which is also relatively easy to install. You need to add the extensions to the list of extensions XML. It also supports local and remote build caches. It supports build scans, and it boosts build out of the box. What I mean, just try to add it to your build and see how faster can it become. I was impressed when I've seen it the first time. For example, this is 2 build scans of the Netty. By default, it doesn't have neither Apache build cache extension nor Develocity, and you can compare that before adding this extension, the build time is more than 2 minutes. After adding extension, it's a bit more than 1 minute. So the speed up is around 45%, and this is without any additional configuration. Also, this build scan is a web link, and we can observe different aspects of builds. For example, consumed resource like CPU, memory, disk, and network. You should be aware that Develocity has a pretty expensive pricing policies, but it's possible to use free version, not a version, sorry, but subset of functionality. What you need to do is to decide if it's okay to publish build scan information to a cloud. In this case, you need to trust third party. And for some organization, it can be a problem negotiating with security engineers, because like third party will be aware about, for example, structure of your build, version of library that you use, and some other aspects. For sure, not your source code, but I don't know, maybe environment variables or so. So once you decide, you can choose one of two options. One option will always forbid publishing build scans, and another will always allow, if it's okay. By default, the parallel build in Maven is not enabled. It means that everything is built in one thread. And there is a command parameter, -t, which has two possible formats, like -t with a number or -t with a multiplier by C. So C is a kind of placeholder, meaning number of cores, depending on the your current CPU on your machine. If you want this parameter to be used by default, you can specify it in .mvn maven config in the list of the parameters, and it will be automatically applied in all environments. If you enable parallel build, you can be surprised that, for example, some tests may fail because they try to use the same fixed port numbers. Address those problems and you will have the build which will much better utilize your multi-core CPU. Let's try to do the same build of Netty, which already has now the Develocity extension, but in multi-core mode with -t. So we can see how workers are distributing building modules in the timeline. So our timelines goes from left to right, and on this build scan, we can see CPU utilization, which is different. For example, on this first 30 seconds of the build and this, just because initially we have low parallelization and now we have pretty good parallelization. So build scans is a valuable source of such insights to find real bottlenecks of your build. If for some reason you cannot use Develocity, which is fine, you can also consider another solution. It's called Takari Maven extension. Just for your information, Takari is a GitHub organization which is created by Jason Van Zyl, the person who created Maven. And you can easily set up an extension that will also generate you locally HTML report, and you also can see the distribution of build cores, and you also can find bottlenecks. So this is good parallelization, this is bad parallelization, only one core is utilized. So you can be confused why, like my machine is 12, I don't know, 16 cores, but it's just not properly loading. This actually can happen even if your project is 300 modules. At some interval of times you can see that your CPU is just unloaded. So actually modularization of your application is a major key point of this optimization. Maven can build different projects in parallel, different cores, that's right, but they should be not depending on each other. So let me now explain how Maven Reactor builds. So what's Maven Reactor? This is a scheduler of a multi-module Maven project. Before it starts building current project, it first resolved all so-called upstream dependencies Upstream dependencies, this can be third-party libraries or other modules of the same multi-module projects, and it will wait executing of all phases of those projects. This works vice versa. If any other module depend on us, all those modules will wait till all phases of current current project will be executed. For example, if we are executing Maven clean deploy, it will execute everything like clean, compile, test, install, and deploy. And only after this, any downstream dependency will be able to be scheduled for building, even if dependency is in test scope. This is a bit weird, but the truth is Maven has atom of the scheduling projects, the project itself. And it's quite different how Gradle does it, for example. We'll talk about this a bit later. Just consider example of 3 modules depending on each other, and if we run the build even with -t 3, 6, I don't know, it will still build sequentially first all phases for the first module, then all phases to the second module, then all phases to the third module. There will be no parallelization. If you are curious about if we can change this behavior, I made a prototype that schedules the build of downstream dependencies when the package phase is executed. So you can see that we are not waiting for running tests, and we can run tests in parallel. This significantly boosts projects where I use this extension. This is experimental. This is so-called builder, which can modify the execution scheduler in Maven. The good news here is that Maven allows to do this without forking it, so it has pretty flexible API, and the extension can change actual behavior of standard scheduler. So now we know how to find the bottlenecks of our Maven build, and the question is, how should we address it? If we know that any project is waiting for all the upstream dependencies, one of the first conclusions here, let's reduce the number of dependencies of this project, because if we remove redundant dependency for this module, our module can be scheduled for build earlier. There is a task called MVN dependency analyze, which can help to find which dependencies are redundant. Just be careful with this, because some dependencies will be needed at runtime. For example, they are discovered like JDBC drivers, etc. But still, many of them will be valid advices to be removed. More complicated thing to optimize Maven build bottlenecks is possible separation of large modules. So for example, if you have a huge module and there is a package with the classes depending on each other and not depending on anything else in the module, you can extract this to a separate module. What we will have with this? First of all, now those 2 modules can be built in parallel independently. Second, any subset package will always, or almost always, have significantly smaller set of dependencies. It means that it can be scheduled to building earlier. And the third thing, any dependency that was depending on our huge module is now sorry, not any, but many of those dependencies who were depending on our huge module now can depend on this smaller module. And this also means that those downstream dependencies can be scheduled to build earlier. So everything is shifting left. We use better parallelization, our build is faster. Also, this is complementary for better ownership and domain design, so you can extract package to a module, assign code ownership, whatever. So this can be a good idea. Another a bit more complicated approach is to split module to a bit different way, so-called API module and impl module, and they depend on each other. If you are using Spring or SPI, You can extract interfaces in API module and all implementations here. This way you can do proper module design, limiting all public functionality which you want to expose and which are not. And you can have an agreement that anybody who is depending on this should depend on API module, while impl is only existing at runtime, maybe integration test as well. Again, this is a pretty complementary for a better domain design and more pure software. I believe you know this picture. It's a bit different with generating. We're not only compiling source code in our projects, but also there are some technologies generating code. Most popular are Protobuf, Avro, also Juke, which generates SQL entities from SQL migrations. So it is very convenient when you mix in the same codebase all your SQL migrations on proto files and all other source code. That's right. But there is a problem with it. When you build this in IntelliJ IDEA cannot recognize this moment when proto files do not match the generated source code anymore. So as a result, for example, what I've seen, some teams have a morning routine during daily stand-up. In the background, they are just regenerating, just in case, all their codebase to keep it up to date. The problem is that we are fully breaking incremental compilation in IntelliJ. So what does that mean? So we regenerate all source code. It works quite well. Then we try to run unit test in IntelliJ. IntelliJ sees that all files timestamps are changed and starts recompiling it again. And the performance is also losing here. So advice here, while this looks not obvious, and this is obviously a trade-off, is to extract code generation, or at least to consider such option, to a library. In case if you have an update, when somebody pulls new version of your branch, they will automatically re-import from the repository the compiled jar. Another small advice is to reduce log output. Surprisingly, log output doesn't only consume a lot of disk space, but significantly affects the build speed in some environments. So maybe you need to address log levels, maybe address some warnings. Some tests can be pretty verbose, but in general it should have positive effect. Let's talk about publishing artifacts. So if you're making a library, it's a must to generate source jars as well. But if you're making an application, in most cases, you should not publish jar, source jar, Java doc, test jar, etc. Maybe only Docker images with proper cached layers. Just revisit what artifacts are you actually publishing, because this can significantly affect the speed of your build. Maven has a thing which I would call test jar dependency. So your SRC test source code can depend on SRC test source code of another module. Just don't do this. If you need shared code between tests, introduce separate dedicated test modules, because this will bring several problems to you. For example, some issues with IntelliJ IDEA. Also, it's not possible to use the option called Maven test skip true. So it will be mandatory for you to always compile with all source code, including tests, even in scenarios where you don't need this. So why you can need this? One of the possible recommendations is how to optimize CI/CD is to have separate pipelines to build the distribution artifacts and do all the rest. So the distribution artifact pipeline should be as fast as possible. And for example, here you can skip test compilation at all. And it should prepare the distribution Docker image or whatever you're using, WAR files, for deployment. And there should be another pipeline checking all unit tests, integration tests, etc. And in absolutely most cases, for sure, deploy should be protected by a requirement that all builds should be green. But it happened with all of us. Once in a while, we have a situation where we have no opportunity to revert, for example, to the previous release, and we have issues on production that can be only fixed with a new release. Or, for example, security breach was just discovered, and it's very critical to deploy as fast as possible. This can once save your life. Maven has a wonderful feature called profiles. So a lot of operations can be redundant by default. For example, some code generation, some verification, etc. You can always run them in your CI/CD environments if needed, for sure. But I recommend you to revisit which operations do you execute by default without any additional parameters. So this is also can be a good optimization to optimize, define default pipeline, default validations, what you do and what you don't do. There are two types of build agents that are used in CI/CD. One is when the build agent is created from scratch every time. It's empty, it's downloading all dependencies. And the second is so-called persistent build agent, which is reused between runs. This can be efficient. For example, you don't need to re-download all the dependencies, so you can save time on I/O operation. Just be careful and find the proper balance. It should not be too short-living, neither too long-living, because if there will be some issue, it can aggregate this issue for a few hours, etc. But again, this is a very good, considerable option. You can also optimize your Maven builds in IntelliJ IDEA, which is not parallel by default. So it's worth to mention that now there is an option called automatic. In the past there was just a checkbox, but also you need to increase the shared heap size to make this properly working. Your IntelliJ compilation can be significantly faster. So just check what value you have for this checkbox. Also, it makes sense to check your activity monitor, even if you have a huge setup like 64 gigabyte Mac laptop, but you run a lot of memory consuming applications like Docker images, IntelliJ IDEA, models, LLMs, whatever, and you consume more memory than you actually have, that your machine starts swapping and all memory operations become slower several times. So this can be surprising why your powerful machine is so slow, because you're swapping, so you need to check what's going on. Take care about the memory page, and there is a thing called memory pressure, which can be green, yellow or red. So if it's yellow or red, this is a reason why you need to reconsider which daemons you need to run in the background. So now let's talk about Gradle a bit. So at Mira, we have a monolith application which is using Maven build, and it's almost 1,000 modules, but also we have around 200 microservices that use Gradle. So I have experience in both, and I would like to say that if the project is not that big, everything can work pretty smooth, and even if you migrate from Maven to Gradle, it can be smooth. Problem starts actually on the large scale. If you have, I don't know, at least 100 modules, it can be a real headache. Just know that if you are considering migration, you need to make it like in one step. You cannot switch in smaller steps. So you need to switch all your engineers or your CI/CD pipelines, all your releases, etc. And you should be ready that something can go wrong. Indeed, Gradle has a lot of advantages like caches and other things. In the combination of factors, like you have warm caches, locally the build time can be impressive. But sometimes it can be like a bit fragile. For example, we have prototype migration of our monolith application, and if you mix working at the console and IntelliJ IDEA, this configuration cache can be easily erased. I found issues that were submitted some time ago in Gradle and they're still active. So again, this can be a problem of large projects, maybe not the small one. Also, the advantage of Gradle build tool is that it gives you remote and local build caches for free. So we discussed Maven. In Maven, there is no build caches, and for example, Develocity extension gives you remote caches only in the paid license. But Gradle build tool has Docker images that are distributed for free. You don't need to buy the Develocity license, and you can boost your local and remote builds. You can use local and remote caches to boost your local and CI/CD builds for free. This is good advantage of this build tool. So just be ready that Gradle, while it's a great thing, has a lot of different pitfalls. It can be slow. It can consume a lot of disk space, a lot of CPU, and you can be surprised that it's so bad. So be conscious when you make a decision if you want to migrate or not. So in general, now you know how to discover the bottlenecks, how to address them, make a conscious choice, and I wish your builds to be healthy. That's it. Thanks. Questions? Yes.
Hi. Have you done any benchmarks comparing like a optimized Maven build with a Gradle build? Like, you know, creating parallel builds for the same projects, for example?
Yes, for sure. So benchmarks include different parameters like CPU load, memory consumption, and others. The problem is that it's it's a bit complicated how to compare cached state versus not cached state. In general, for example, the same Gradle build for the same project that contains 1,000 modules needs plus 10 gigabytes of CPU and 10 gigabytes of memory, sorry. And it works the first time. The build time is almost the same because we optimized our build in Maven pretty good. So the first execution is pretty good. The repeated execution of Gradle build can be better, but again, the price can be pretty high. Plus 10 gigabytes is more than 1/4 for my laptop, which is 36. And I'm not quite sure that it will be a good compromise to suggest to our engineers because we run, IntelliJ, LLMs, etc. So you need to choose. Other questions? Okay, thank you very much.